Hi everyone! In today's lesson we're looking at Chapter 6, Section 6, Special Quadrilaterals. Our objectives are to identify special quadrilaterals based on limited information and prove that a quadrilateral is a special type of quadrilateral. Our standards are GCO 11. Example number 1. Identifying quadrilaterals. Quadrilateral ABCD has diagonals that are perpendicular. What type of quadrilateral meets this condition? Well, there are three types of quadrilaterals that meet this condition, so draw and label each type of quadrilateral. Our first quadrilateral is a rhombus. We know that from Theorem 6.11 from Chapter 6, Section 4, that the rhombus has perpendicular diagonals. Our next quadrilateral is a square. Squares are rhombuses, so it also has perpendicular diagonals. Finally, we have a kite. From Theorem 6.18 from Chapter 6, Section 5, we know that kites have perpendicular diagonals. Checkpoint problems number 1, 2, 3, and 4 are yours. In checkpoint problems number 1, 2, and 3, you are given the figures. You are to identify the quadrilateral using the most specific name for it. Checkpoint problem number 4, we have a quadrilateral that has diagonals that are not congruent. What type of quadrilateral meets this condition? Draw and label each type of quadrilateral. Example number 2, proving a quadrilateral is an isosceles trapezoid. Show that QRST is an isosceles trapezoid. Remember, an isosceles trapezoid has two parallel line segments and its legs are congruent. So there's two steps that we need to do to show that this trapezoid is an isosceles trapezoid. The first step is to show that QRST is a trapezoid by proving that line segment QR is parallel to line segment ST and line segment QT is not parallel to line segment RS. In order to say that line segments are parallel, they have to have the same slope. So we need to find the slope of all of these line segments. Remember, your slope formula is lowercase m is equal to y2 minus y1 over x2 minus x1. So change in y over change in x. The slope of line segment QR is equal to 7 minus 5 over 4 minus 2, which reduces down to 1. The slope of line segment ST is 6 minus 1 over 8 minus 3, which reduces down to 1. Slope of line segment QT is 5 minus 1 over 2 minus 6, which reduces down to negative 4. And the slope of RS is 7 minus 6 over 4 minus 8, which reduces down to negative 1/4. So the slopes of line segment QR and line segment ST are equal. So line segment QR is parallel to line segment ST. The slopes of line segment QT and line segment RS are not equal, so these segments are not parallel. Step 2, show that QRST is isosceles by proving that line segment QT is congruent to line segment RS. Remember the distance formula, lowercase d is equal to the square root of x2 minus x1 square plus y2 minus y1 square. So QT is equal to the square root of 2 minus 3 square plus 5 minus 1 square. Simplify that to get negative 1 square plus 4 square. Take the square of the numbers, add it, and we get the square root of 17. RS is equal to 4 minus 8 square plus 7 minus 6 square. Simplify that to get negative 4 square plus 1 square. Take the square of the numbers and add it to get the square root of 17. Because QT is equal to RS, line segment QT is congruent to line segment RS. Because QRST is a quadrilateral with exactly one pair of parallel sides, it is a trapezoid. Because its legs are congruent, QRST is an isosceles trapezoid. Example number 4, identifying a quadrilateral. What type of quadrilateral is ABCD? Explain your reason. From this image over here, we can see that angle BAC, which is this angle over here, is congruent to angle ACD, which is this angle over here. So you can conclude that line segment AB is parallel to line segment CD using theorem 3.8 from chapter 3 section 4, which is the alternate interior angles converse. Similarly, angle ADB, which is this angle over here, and angle DBC, which is this angle over here, are congruent, so line segment AD is parallel to line segment BC. Because ABCD is a quadrilateral with both pairs of opposite sides parallel, ABCD is a parallelogram. Because ABCD is a parallelogram and each diagonal bisects a pair of opposite angles, ABCD is a rhombus. Alright, checkpoint problems number 5 and 6 are yours. Checkpoint problem number 5, in example 3, can you conclude that ABCD is a square? Explain. Checkpoint problem number 6, what type of quadrilateral is ABCD? Explain how to prove it. Alright, that's it from me. I will see you all soon.